Hello everyone, you are all welcome to lecture number 963, and today's topic is polyisoprene rubber or synthetic natural rubber. Why we are saying synthetic and natural rubber? The reason is that this polyisoprene rubber, they are synthetic, but they are made up of isoprene units. The monomers are isoprene, and the multiple of those monomers, that is isoprene, is known as polyisoprene rubber. And since this isoprene multiplication is there in natural rubber also, what natural rubber we are getting from plant sources, they have also the multiplication or polymerization of isoprene, that is C5H8. That C5H8, that is called isoprene. And this isoprene unit, this is your isoprene unit, that is C5H8. So it will be joining like this. Then it will be joining like this, and then it will be joining like this. So in that case, this isoprene units, they are forming the polymer. This is your monomer, and that monomer is nothing but C5H8, that is isoprene unit. And this isoprene unit is joining in millions, and that gives the isoprene, that is polyisoprene polymer. And that polyisoprene polymer is called polyisoprene rubber. And this isoprene unit C5 is natural. The only difference is that once we are doing the synthesis of, that is polyisoprene rubber, there is no any contamination. But natural one is having some antioxidants, protein, because in nature along with that there is this molecule. And first time Firestone tire manufacturer or company, they were successful to manufacture polyisoprene or synthetic natural rubber. And then later on, Goodyear tire company, they also started producing polyisoprene rubber or synthetic natural rubber. The only thing is that main thing, how to manufacture, from which source we should obtain isoprene unit. So that, these companies of the rubber, that is Firestone and Goodyear, they tried several methods, and all these methods to get isoprene C5H unit was very costly. And then later on, by the cracking of petroleum, by pyrolysis, all these techniques were used, and from acetone and from butadiene. So with that cracking of this and some other reaction by using Ziegler-Natta catalyst, they were successful to get these polyisoprene rubber or synthetic natural rubber. So all these I am going to give one by one. So here, number one, a number of stereospecific polymerization of isoprene, that is monomer of natural rubber. That isoprene is actually C5H8, I have already discussed in the beginning. That is the monomer of isoprene, polyisoprene rubber. To cis 1,4 polyisoprene have been carried out. For example, polymerization of isoprene in presence of Ziegler catalyst, very powerful. Ziegler catalyst is used for different type of polymerization. Gave the product known as ameripol and SN. So ameripol SN was the name of the product. However, polyisoprene rubber has been synthesized first time by Firestone Rubber Tire Company. So first time Firestone Rubber Company synthesized polyisoprene rubber from isoprene unit using lithium as catalyst, and they called their product, they named their product coral rubber, and coral rubber was synthesized by Firestone Company. Similarly, Goodyear Tire and Rubber Company is also very popular, well-known. Goodyear Tire Company synthesized polyisoprene rubber in presence of Ziegler catalyst. So the Firestone used lithium as a catalyst, and Goodyear used Ziegler as a catalyst, and they named their product as Nutsin. Number 2, the synthetic polyisoprene rubber or synthetic natural rubber has the same chain structure as the natural rubber. The natural rubber, that's why it is called synthetic natural rubber, because this polyisoprene rubber and synthetic rubber, which are made out of polymerization of isoprene C5H8 isoprene units, they are natural, because natural rubber is the multiplication of or polymerization of isoprene units. So once we are doing the synthesis of the same isoprene unit obtained from any source, that source I am going to discuss, then it is called synthetic natural rubber. The natural rubber, the only difference in natural rubber and synthetic natural rubber is that in natural rubber, which is extracted or obtained from plant source, they contain antioxidants, and those antioxidants, they are from protein molecules. But once we are doing the synthesis of extra pure isoprene unit, we will not get those antioxidants, and because of that reason, the synthetic natural rubber is more resistant to atmospheric oxygen, to heat, and the quality is good. So the only difference being that it lacks the natural antioxidants derived from the proteins in the natural rubber, because the synthesis of synthetic natural rubber is carried out with highly pure isoprene molecules. The synthetic natural rubber is more resistant to atmospheric oxygen, heat, and cracking than natural rubber. So, the starting material, isoprene, how to get isoprene in order to do the synthesis of polyisoprene rubber or synthetic natural rubber. So here I have given some 3 methods to get the isoprene units as a starting material for the synthesis of polyisoprene rubber. That is, how to get starting isoprene C5H8 monomer material. The methods are given here. Number one, that is starting material is amyl alcohol. When it is treated with ZnCl2 and then with chlorine, you will get chloro derivative, and finally treating with alkali at high temperature, that is 500 degrees centigrade, it will be converted into C5H8, that is isoprene unit. Second, again the starting material is amyl alcohol, is treated with hydrochloric acid, and then alkali, that is at 500 degrees centigrade, you will get isoprene unit, that is C5H8. Number 3, when acetylene, that is CH3 bond, CH plus CH3COCH3, that is acetone. When acetylene and acetone is mixed, and partial hydrogenation will take place, and by the removal of one molecule of water, you will get CH2, CH3, CH2, that is your isoprene unit, C5H8. And number 4, that is lactoprene. Actually, lactoprene is a copolymer of polyethyl acrylate with about 50% of beta chloroethyl vinyl ether, and it is synthesized from lactic acid also. From lactic acid we can get this lactoprene, and it is added for cross linking in the rubber, just like vulcanization. So it is given here. We will take ethyl acrylate and plus beta chloroethyl vinyl ether, and these two, when they are treated, we will get the polymer of CH2CH-COC2 is 5, CH2CH-COC2 is 5, CH2CH-COC2 is 5. All the long chain will be formed, and that is called lactoprene. So with this I will stop. Thank you very much for watching the lecture.